My name is Max Weber. Together with our team, we built Storydo.com. You can create Instagram stories in advance, and our platform auto-posts them. And here I'm just trying to document the things I did right or the things I did wrong. And today, I guess that was a classical example of over-engineering. So the root cause or the biggest problem at the moment relating this pull request is that our servers track how many credits customer currently has, and therefore we use event sourcing. So every time the customer buys credits, the balance increases, and if we spend credits, for example, when he creates an AI image via our platform, the credits decreases. Everything, the credits are tracked in US dollar, but here the issue is that we store those events in Datomic, which has some other drawbacks which I will not go into because Datomic doesn't like to have really large values. But on the other hand, the problem is on our production servers, we have around 300 active customers, but also a few which just tried out our product and are still in demo mode. And when the system starts up, the event sourcing was done in memory, meaning the events was read from Datomic, and then we use an atom here, this one, to store the credit balance and the subscription status. So does the customer currently have a subscription or not? So there we're using still a subscription so that every month the credit balance increases and the customer doesn't have to manually upgrade the credits balance. It's kind of a prepaid model, but you kind of have to do this nowadays because if you integrate some AI services into your product, it can get expensive very fast. For example, if you generate a video with Google Veo 3, then you may be paying $2.50 for just 5 to 10 seconds. And but it took me quite some time today to come to this conclusion. And here I also have another pull request where you can see from the lengths here that's way more complicated, and there I tried to introduce, besides Datomic, also SQLite, where we store those events and not only the billing events but also later on the events from our AI integrations when we do more sophisticated things where we have to track how much tokens was spent and then based on this calculate how much it cost. And in the meantime, today I used this really cool SQL GitHub Closure. So this product here, it's really cool. It essentially gives you an Closure Atom, but everything gets stored in a SQLite database. But then I noticed, okay, you have to specify here the key where to store it. And for us, the problem is when there are, let's say, 1,000 tenants, customers on one production server, then you also, or at least this library would spin up a one SQLite connection for each atom. So instead of state here, you would we track UUIDs. Also, we use UUIDs to identify the customers, and then we could, for example, do a UUID, and this is the default value, which is then used. So my initial thought was, okay, let's spin up Cloud Code and modify this, and I also did this, but after 2 hours or so, I deleted my fork because I was noticing that it's essentially a mismatch for my use case, because in a Clojure atom, the convention is that you essentially can put in every value. The problem for me was that I somehow need to enforce that it's a map. So then my plan was to just use a SQLite table, which essentially has a key and a value column, to realize the key value pairs of this map. But I was almost like, yeah, come, let's do it, just get this out, because as I said, it will solve a little bit annoying problem that we at the moment have when we roll out this thing, due to the event sourcing being replayed in memory and so on. And there's quite a lot of events to replay. The CPU spikes, and if there are many customers on one production server, then it's kind of really slow to use the web application for a few minutes. But lucky enough, I said, okay, let's look at the code and don't deploy AI slop, and that was the right intuition. And it kind of, for example, every time it read the whole table, so all key value pairs, which from the atom notion semantic is totally okay. But in the end, we essentially just need to solve this one problem, that we don't get this huge CPU spike. And that would probably have made it worth if we would have used my fork of this library, because it would have read the table all the time. And as you can imagine, the credit balance is almost shown every time you open our application. It's in the top bar, and therefore it needs to be queried. So here I really used probably one of the most simplest way to cache the things. We have a cache tier here that's folder mounted into the Docker container we use to run the application, and it's just reading from the file, parsing the Eden data, and it also writing the cache. And it's doing here the equals check regarding the db/t, that's the t value of our Datomic database. I don't know, maybe I removed this. I need to review the stuff tomorrow again before I deploy it. But you may also wonder why I'm just reading from the file system. We use cell-based architecture and run on dedicated servers. There we have the downsides. Let's be clear, but one of the luxury details is that you can read very, very fast from the disk, because it's not something attached via the network, which you normally have on a cloud provider. And there it's just an NVMe drive, and it's super freaking fast, and it will deliver this mostly under 1 millisecond. And it's also great that you can just inspect those files. So maybe I have it here. It's just for my local development environment. Yeah, and it's basically a little bit of Eden. We track the transactions which actually top up the credit balance. Then we have the credit balance, the line item total, so how much the customer has spent. But you can imagine that there accumulates a lot of events if their customer using our application for years. Also a thing, customer could have multiple subscription. So maybe it has canceled the subscription, then resubscribe, then you have to deal with multiple subscriptions. But honestly, the event sourcing there is pretty straightforward, and I also pretty much like this approach because you can replay the stuff. And for example, if you made a mistake calculating the refunds and so on, which we did in the past in one case, and then it's pretty easy to get rid of those mistakes. And there's much more to cover, but I think for this video I covered what I like to document. Hope you find it interesting. See ya.